Welcome back to KSS, Kindle Science Station, which is all about loving science kindled through toys and objects around us. I have chosen a topic on sundial. Friends, this topic may seem to be common, but believe me, when I went little deeper to understand the principle and working behind the sundial, I was amazed to see how much our ancestor knew about science almost 3000 years ago. In part 1 of this video, I will focus on the theory behind the sundials. So let's go. As we saw in the last video, the sundial was the first clock. It tells the time by the position of shadow it casts when the sun shines. The very first sundial invented were less sophisticated devices, consisting simply of a rod stuck vertically into the ground to give approximation of the time. Later, more sophisticated and accurate sundials were invented, which required less adjustment related to seasonal change and were less prone to errors. Let us first understand what constitutes a sundial. It has a flat plate or the dial, normally circular in shape. It has a triangular plate called gnomon. We will see in detail that gnomon should point to a predefined direction and should also be set to a particular angle depending on the area or a place where the dial is to be used. When sun is out, the shadow of the gnomon falls on the dial. As the sun appears to move through the sky, the shadow moves on the different hour lines, which are marked on dial to indicate the time of the day. This is just to summarize again all parts of sundial labeled in this picture. Let's now understand the setting of the gnomon. Gnomon should point towards the true north and is set to an angle to the horizontal which is equal to the latitude of the location where dial is used. So let us first recall what is a latitude and what does the true north actually means. Hope you remember latitude, also called parallels, are imaginary lines that divide the earth. Latitude is 0 degree at the equator and reaches 90 degree at the pole. Each degree of latitude covers 111 kilometers on the earth's surface. Remember, wherever you are on earth, the latitude lines will always be parallel, that is same distance apart. Coming back to the angle of gnomon, to make it parallel to the earth axis, it must be at an angle which is the latitude of the place where the dial is used. Imagine we are using the dial at some point P on the earth, which is on a latitude L. To have a gnomon parallel to the earth axis, the angle it should make with the horizontal must be equal to latitude. If you see the triangle OPN, you will see with little mathematics that angle N will be equal to the latitude L. Also, gnomon must point towards the true north. So, what is a true north? Let us see. So, true north is the geographic north, the direction that leads to the North Pole. It is calculated by an imaginary line through the earth rather than by using a magnetic compass. Pole star or Polaris is taken as a reference north for the northern hemisphere. The magnetic north is the direction where the needle of the compass point north. So I hope you understand the difference between the true north and a magnetic north. So while setting the sundial or the direction of the gnomon, we should actually not use the magnetic compass. The difference between the true north and the magnetic north is measured by an angle called a magnetic declination. The declination is taken positive if the magnetic north is towards the east of the true north as shown in the figure. Let us take an example. The magnetic declination in Delhi is about plus 1.27 degrees. So, the error in sundial, if we use compass to find the north, is about 5 minutes because 15 degree corresponds to 1 hour, and if you calculate 1 plus 27 degrees will correspond to almost 5 minutes. With this, I hope you are clear on the theory behind the sundial. In the next part, we will make our own sundial and we'll see if we are accurate enough to get the correct time. So keep watching this channel, Kindle Science Station. I will soon post how to make our own sundial. Bye bye for now.